Alright, so now that we've talked about ratios and we've talked about proportions and worked a couple of problems, we are going to work on our next objective, which is to solve problems involving proportions. Problems in this particular instance meaning word problems. And so, as we previously discussed, a ratio is a comparison using division of two quantities of the same kind, both expressed in the same units. Remember that, both expressed in the same units. And then, of course, a proportion is an equation stating that two ratios are equal. The one thing we have not discussed yet is that in regards to proportions, there are two kinds of proportions: a direct proportion and an inverse proportion. So, a direct proportion basically means that if one part of the portion increases, the other part will increase as well. On that same note, if one part decreases, so will the other. So that is a direct relationship, and those are the proportions that we have been working with thus far. But in order to determine whether or not you need to set up a direct or inverse proportion for your problem, you need to read the problem. So let's go ahead and take a look at this landscaping problem. We're dealing with a mixture of plant food. So a mixture obviously is three things added together. You mix them together and you have a new solution. So the mixture is prepared by combining, we're adding them together, 3 parts of a concentrate with every 16 parts of water. So written as a ratio, we can say 3 parts. We'll use C for concentrate. We'll use the colon. We're making a ratio. We could use the word 2. We could write it as a fraction. But for right now, I'm going to go ahead and use the colon. Excuse me. So that 3 parts of concentrate goes with every 16 parts of water. H2O, I'll use that. So the ratio here is basically 3 to 16. Remember, in ratios, we don't use the units. I'm just writing them right now to show you how to set up your problem as a direct relationship. Because if we have 3 parts of a concentrate to 16 parts of water, that's 19 whole parts there. If we increase or decrease the whole, we have to increase or decrease the parts. That infers that this is a direct relationship. So the question in the word problem says, how much water should be added to 12 ounces of concentrate? We want to know how much water. And it's going to be in ounces, because the question says how much water should be added to 12 ounces. Now, ounces could be the same thing as a part. The part is kind of like a unit. It's vague. A part could be anything. It could be an ounce. It could be an inch. It could be whatever the unit of measurement is. So, in this case, because the question is telling us that the second part of the proportion is using ounces, our answer will be in ounces, although you'll see when we get to the end of the problem that you could also put parts. It's correct, just not as correct. So here we have 2 ratios. So now guess what? We're getting ready to set up a proportion. And like I said, once again, it's a direct proportion. So I have 3 parts concentrate to the 16 parts of water, and then 12 ounces of concentrate to how many ounces of water? So we set it up like this. 3/16, that's my first ratio, is equal to 12. And remember, we dropped the units. when we're creating the proportion, when we're dealing with ratios, we drop these units. I just put them so that you could see the difference between the parts and the ounces. So I have 3 parts to 16 parts is equal to 12 ounces or parts over how many ounces or parts. So this is our initial ratio, or proportion. And if you remember correctly from the last lesson, we can use the cross product rule to figure out what x is. And so the cross product rule says if a over b is equal to c over d, then a times d is equal to b times c. That's the cross product rule. Alright, I call it the cross multiplication. Some people call it the butterfly rule, and I'll show you why right now. So basically, you cross multiply. You have cross products, or if you draw it out visually, it looks like a butterfly. So we're going to take the 3x, and it's going to be equal to 16 times 12. Now here is where it's really important to notice that I'm showing work. Okay? So I can multiply the 16 times 12. I can multiply that out like I've been doing. 6 times 2 is 12. Carry the 1. 3. Placeholder. 16 times 1 is 160. Add those together and you get 192. I can do that, or I can get my handy dandy calculator and say that 16, oops, let's turn it on first. Go ahead and clear that out. 16 times 12 is, well, we got some light. 192, which is exactly what I got right here, but it never hurts to double check. So, I've got 3x is equal to 16 times 12. Now I'm going to rewrite, and I can put rewrite if I want. When I use this arrow, I'm usually rewriting. So I'm going to say that 3x is equal to 192. Now I need to get that x variable by itself, so I'm going to divide by 3. If I divide by 3 on one side, I have to do it on both sides. So here the 3 cancels out. Now I can kind of clean up the problem a little bit, get rid of those 3's that I canceled out, and I can say that x is equal to 192 divided by 3. I'm going to continue towards solving it. Once again, this is showing my work. Okay? So, let me get that handy dandy calculator back out now. 192 is still there. I'm going to go ahead and divide by 3, and I get 64. So x equals 64. And remember, this is how much water? 64. But we're talking about ounces of concentrate. So for every 12 ounces of concentrate, it's going to be 64 ounces of water. Or, not as correct, but still correct, I could say 64 parts of water. Either would be acceptable. This is the more correct answer.